is that the regular hexagon must have equal distances. It is always of equal distances. Each line AB is equal to BC in magnitude of length. CD is equal to DE is equal to EF is equal to FA. All of those lines have the same distance. Are we together at that point? Can I hear from you?
Yes, teacher.
Yes, that was the trick. Now, um, having got that trick, what we are doing,
Mr. Pardon.
corrections. So, having got that trick, having got that trick, having got that trick, you had to get the angle through the angle of action of that line of that force along SC. It's the angle of action to the horizontal. You had to look for that angle. Since that distance is equal to that distance, that angle must be the same there. But we know this angle here. What's that angle? Who can tell me that angle at B? We know the interior angle in a regular hexagon. What's that angle at B?
120.
I beg your pardon? It is?
The angle at B is 120.
It's 120 degrees. Amina, do you agree? Amina, do you agree with that solution?
Yes, teacher.
Elizabeth and the others, do we agree with that solution?
Yes, teacher.
Okay. The angle there is 120. So if that angle is 120, now that means this is that triangle. This is that triangle. If I draw it out, you will agree that this is that horizontal is SC. This is the point B. This is the theta that I'm looking for. I'm looking for that theta, but the other angle is 120. So you will agree that 2 theta plus 120 degrees, being a triangle, must sum up to 180. So 2 theta is 60, meaning that angle to the horizontal is 30. The force makes with the horizontal is 30 degrees. So I think we are now good to go. That force acting along SC changed the usual regular hexagon action. So it's what you had to look at keenly. So we can start off with the resolving for components acting horizontally. Okay, can we start with that 2 Newton force? Was its horizontal component, that 2 Newton force? Since now we know it's the angle to the horizontal. Can somebody tell me its horizontal component? Since we know now its angle, okay, David suggests that the angle is 2 cos 30. Is he right? The angle is 2 cos 30. Is he right?
Master observation is a negative.
When you look at the direction of action, if we put out a triangle from that point where that that is how the triangle looks like. This is A, This is A, that is C. The force's origin is point A, its destination is C. This is not B, it's this point here. It's not B. So this angle here is 30. This is our force 2 newtons. I want to resolve it horizontally and vertically. So is the horizontal component negative? Is it really negative?
Answer is a positive 1.7320.
Give me that exact value. It's 2, positive 2 cos 30. Agree? Let's first leave it in exact form. Huh?
Okay.
Let's proceed to the other force. The other force is the one acting along ED. What is its horizontal component? The force acting along ED, what is its horizontal component?
It is 5.
Positive, negative?
It is a positive.
Positive 5. Next force, the 3 newtons force acting along AE, which is in line with our vertical direction. What is its horizontal component? The 3 newton force.
A
It is 3
zero.
cos 90 is 0.
It's a 0, which is 3 cos 90. Then the 4 newton force, what is its horizontal component? The 4 newtons
It is
force.
negative 4 cos 60.
Do we agree? Amina, do you agree with that solution?
No, master, I need proof.
Uh, Now the triangle for that force is what maybe I can sketch. The triangle for that force is like that. This is its point A. It is acting upwards to point F. This is the 90. Which angle is here, class? Which angle is here, Amina? If the interior angle is 120, what angle is that one with the double blue axe? Amina, which angle is there at point A? Amina?
Master, I'm not sure.
Amina, which angle is inside here? What's the interior angle of a regular hexagon?
120.
120. This is a straight line. So which angle is this one? Angles on a straight line must add up to 180.
60.
Yeah. Don't forget those things. Eh? Have you got it?
Yes, teacher.
Yeah. So the horizontal component, will it be negative or positive from A? Will it point towards this side or the other side?
Master, negative.
Yes, it's negative. Then the vertical component is positive. So we agree with negative 4 cos 60 as suggested by David. So that becomes our summation x. This is 2 times cos 30 is root 3 out of 2 plus a 5 minus 4 times cos 60, which is 1 out of 2. Are we there? One, one.
Master, we are there.
Hmm? Eki
Yes, teacher, we are there.
simanyi situukangayo babadde bangambye ziyinza okuggwa wiiki eno. Naye nja kusooka mpitewokko nga wooli tujjire tutunulemu tulabe. Yes, sir. Saana. Yes, sir. Naawe bulungi. Right. So that one becomes root 3 plus, is that 5 minus 2, which is 3? So our summation of x is actually 3 plus root 3. Keep it in that exact form. Keep it as a surd. Can we go to the summation of y, the summation of the vertical components? Can we start off with the vertical components? What is that arrangement that we do have? Uh-huh.
2 sine 30.
Good. Uh, 2 sine 30. 2 sine 30. That's the first one. It's positive. I think we agree with Amina. The next force is 5 newtons. What is its vertical component?
5 sine 0,
Which is what?
which is a 0.
Next force is 3 newtons. What is its vertical component?
3 sine 90, which is a 3.
Which is a 3. Next, which is a 3, sorry, which is a 3. Next force, the 4 Newton force, what is its vertical component?
Is 4 sine 60.
4 sine 60. Elizabeth, do you agree?
It's a plus 4 sine.
Good. That is 2 times a half plus 3 plus 4 times root 3 out of 2. That 2 over 2 is
Yes,
1
teacher,
plus
I agree.
good. This is 2 root 3. This is 2 root 3. That is the summation. That is the summation of y. Therefore, the summation of y is yet also surd, which is 4 plus 2, the root of 3 in newtons. So keenly, you had to look at those statements that way. Have we understood the resolving for that question? Have we
Yes,
understood
master.
the resolving for that particular question, class?
Yes, teacher.
How it had to look like? Alright, let's go to the resultant. So straight away, before we get the direction, let's look for the resultant. So now, the resultant force R is the square root of the summation of x all squared plus the summation of y all squared. It's advisable not to rush to get the decimals. Keep those surds intact. So the first surd is 3 plus root 3. 3 plus root 3 all squared. The other side is 4 plus 2 root 3 all squared. Then square that one, square that one. That will be 9 plus, uh, when you expand that one, you will get 6 root 3 plus 3. Let's check. Let's check whether it gives you that. Expand normal and see. That is 16 plus 16 root 3 plus, when you square 4 times 3, you will get 12. Squaring 2 root 3. 2 root 3 squared is the same as actually 4 times 3. After squaring root 3, you get 3 squaring 2 will give you 4, which is a 12. Then 9 plus 16 is 25. Actually, that one is the same as someone getting the 9, add a 3, add a 16, add a 12. All those are constants, landing to 40 plus 6 root 3 plus 16 root 3 is yet a 22 root 3 and a root and yet another root. So right at that point you can approximate 40 plus 22 root 3. Square root of that answer is 8.8377 newtons. That way, that way, that way. Now, as someone checked my substitution,
It's right, teacher.
good, thank you. Now let's get the angle. Let's get the angle. Let's compute the angle at which that force acts. So for you to easily compute that angle, get the summation of x in decimals. What is the summation of x? So for direction, for the direction, for the direction, we need to compute the summation of x. That's 3 point root 3. What is it approximately equal to? Then compute the summation of y. That 4 plus 2 root 3. What is it approximately equal to 3 decimal places? As someone computed that one?
Summation of x,
Mm,
4.732.
good. Then summation of y, I say 7.464, also positive. Since they are both positive, now I can sketch. I can sketch. Uh, a diagram, a force diagram for the resultant force. For the resultant force, keep in mind that this is your origin with respect to the original diagram. Call it point A. So summation of x is positive. This is our y. This is our x. Summation of x is positive 4. Positive 4. 4.732. Summation of y is 7.464. So those two, if they meet at that point, if they do meet at that point, then what will be the line of action? 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 What would be the line of action? So the tan, we have already used the theta. can use alpha here. The tan of alpha will equal to the opposite. The opposite is this one here, whose distance is equal to that distance, to that vertical distance, which is the 7.464. The adjacent is this one here, whose length is the summation x, 4.732. So what is that angle to two decimal places? Has someone computed it? Someone computed that angle. I see a 57 rather, point 63 degrees. Do you agree, class? Do you agree with that solution?
Yes, teacher.
All right. So that means,
Yes.
thank you, thank you. So that means our solution. That means our solution is our solution is um, that means our solution is that conclusion as the resultant the resultant the resultant is, you mentioned that that magnitude, the resultant is 8.837. The resultant is 8.8377 newtons, acting acting at an angle of 57.63 degrees, acting at an angle of 57.33 degrees, 63 degrees rather, um, with 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 the force that was alongside the horizontal. We have we just have the line AB. We don't have a force on that line, so it would be better if you just say uh, acting at 57.63 degrees with the line with the line AB with the line AB. Since there is no force on it, indicate that you're respecting the positive direction of AB. I hope there is clarity in that question if we found the challenges when doing it. Are we together, members? Is it okay? I'm giving you some few minutes to check your work, what you did, uh, compare it with what I've submitted. Compare it with what I've submitted, and you should be able to break conclusion. You should be able to break conclusion. If we are good to go, you let me know.
Master, just to ask that is resultant the same as magnitude?
Yes, magnitude of the resultant force is the same as just resultant force. Okay? Unless if they say express the resultant force in vector form, then you may not compute the magnitude, you may just present the you may just present the, the resultant in vector form. Okay?
Okay, master.
So I would expect us to have understood how to obtain resultants uh, on a figure. That figure may be a rectangle, it may be a square, it can be a hexagon, it can be it can be uh, a simple trapezium. A figure, any figure can be set. That's what I want to emphasize in my submissions. Any figure can be set. You should look for, if you have a question bank which is up to date, look for the figure that was set in 2019, the figure that was set in 2018. This chapter of resultants was set where learners were asked to obtain what we call the resultants. So this brings us to the end of this chapter. So unless otherwise, that marks the end of resultants, the topic resultants and components of forces. So if you feel you have any issue, let me know before I proceed to the next chapter. You people are going to be so good in mechanics if you decide to not put these ideas I've been giving you aside. Keep them around you. You will not fail paper 2. Paper 2 will be very easy as paper 1 is for you in the final exams. So can I know if there is any challenge or any query I should clear before submitting the next topic? Okay, if there is no query, I want to mention that our next chapter is momentum. Our next chapter is momentum. Momentum. If you've been updating your notes on a new heading, write this momentum. Momentum becomes our new chapter. Momentum. 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 So, what are we expected to study under momentum? Under momentum, we are expected uh, we we are expected to one apply Newton's laws of motion, to apply Newton's laws of motion. B, we are expected to calculate the impulse. As we apply Newton's laws of motion, we are going to be applying them to elastic and inelastic collisions. Then we are expected to be able to calculate the impulse. Those are the two bits that we must brainstorm as regards what we call momentum. So momentum, some books refer to that chapter as momentum and impulse, but basically we want to emphasize that we are just going to do what we call momentum, simply momentum. Then impulse is looked at as a subsection in this. Impulse is looked at as a subsection in this case. Are we there? Have we put down the heading and what we are expected to understand? Are we there, class?
Yes, teacher.
Good. Good. All right. So of course, we need to remember that under momentum we appreciate the concept of conservation, the concept of uh, conservation of linear momentum, the principle of conservation of linear momentum. We have to appreciate that, the principle of conservation of linear momentum, which states that, I'm just talking, don't think I'm writing. The principle of conservation of linear momentum, which states that, by the way, I believe someone here might be remembering that concept. How does it state? The principle of conservation of linear momentum. Anyone who remembers it? People now are scratching their heads to remember physics. Yeah, I don't want you to remember physics. Okay, let's begin it at a lay point.
When two bodies collide,
Uh-huh. Uh-huh.
Master.
Hey, you say it.
When two bodies, when two bodies collide,
Mm.
Master. When two bodies collide,
Okay. Uh-huh.
Their total momentum before and after collision is the same.
Yes, correct. Momentum before collision, that's the principle, is equal to the momentum after collision. That's the principle. Okay, let's begin at the definition of momentum. At the definition of momentum, this is the product. This is the product. This is the product of mass and velocity velocity speed or speed of a body uh, in motion in motion. It may be at rest, but that product is what we call momentum, which is denoted as capital M, and the mass is taken as small m here, and the velocity stroke speed is taken as v. So the product of m and v is what we refer to as momentum. So that one, the capital M is our momentum. Capital M is the momentum. This one here is the mass of the body, mass of the body. Then that one is the velocity of the body uh, in motion. That is momentum. Now we have what we call the units, the units, uh, the units of momentum would be the SI units. The SI units. The SI units are mass is in kilograms, velocity is in meters per second. Kilogram meters per second can be deduced as the units. All right. Uh, uh, or if you don't say kilogram meters per second, you can say Newton seconds. Or that is the alternative, Newton seconds. That is taking. That is if someone says someone takes this to be a force, the mass if is it's expressed as a force, then you can multiply simply by time. Force times time also remains as momentum. It remains as momentum. Having taken force to be in newtons, which is mass times acceleration. Mass is in kilograms. Acceleration is in meters per second squared. Now, when you multiply this by s, if you multiply it by s, the force when it's hit by s, it takes you to kilogram meters per second, which is the original unit. So we notice that even f times t, and this f times t, we are yet to define it as well as another definition of another concept. I hope I'm talking to someone here. Okay, proceedingly, you can be asked to to uh, to find the magnitude of momentum. For example, for example, example, find the magnitude, find the magnitude uh, of momentum. Find the magnitude of momentum. Find the magnitude of momentum of find the magnitude of momentum of a cricket. of a cricket of a cricket ball of mass 350 grams of 350 grams uh, thrown 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 at a certain speed thrown at a certain speed at 20 meters per second. We want the magnitude of momentum of a cricket ball. You know its mass, you know its speed. So mass or capital M, that would be momentum. It is mv, but our M is 350 grams. Change it to kilograms straight away. Change this to kilograms. I don't know what you would say. Then leave the speed as it is in meters per second, because we believe that can bear the same unit, kilogram meters per second. What would you do to that mass class
Divide by 1000.
to change it to kilograms? So you get 350 divided by 1000, uh, which becomes, I think, 3.5. Is it so?
Master, it is 0.35.
Sure? Yep, it's 0.35. 0.35 kilograms. So this is our mass, this is our velocity. Now the momentum will be 0.35 multiplied by the velocity, which is 20. Now what will the momentum become? Isn't that momentum 7? We agree, class? 7 Newton seconds. Do we agree, members, with that value?
Yes,
Yes,
Master.
teacher, it's 7.
B. Part B, everyone try this. Find the magnitude of momentum uh, of uh, a, a trolley of a trolley uh, of a trolley measuring 4 tons, moving at 0.5 meters per second. What's the magnitude of momentum here? What's the magnitude of momentum in part B? Let everyone try that. Let everyone try that. Are we through?
Yes, we are through.
So again, our momentum is going to be the mass times the velocity. Our mass is 4 tons. Can we change this to kilograms? What will it be in kilograms? Our
4,000.
our velocity remains
4,000.
yeah. You just multiply tons by 1,000 to change it to kilograms, so you get 4,000 kilograms. That will be 4,000 times the velocity, which is 0.5, and you get what?
2K.
2,000.
2,000. Is it?
Yes.
Yes.
MS. Units.
2,000 Newton meters. 2,000 Newton meters as the momentum for that case. Let me hope you people do write these notes.
Yes, teacher, we have them.
Okay,
We are writing.
okay. Now, uh, note. I want to note that in red, note. Uh, suppose, suppose the velocity, suppose the velocity, suppose the velocity of a body, suppose the velocity of a body changes from u to v along the motion during motion. It's during motion from u to v during the course of its motion during the course of its motion. uh, then during the course of its motion, then then such a body such a body will will have will have will have then such a body uh, such a body will have will have an initial momentum will have an initial momentum will have an initial momentum which is capital M1 equal to its mass times the initial velocity u, and and a final momentum which is what we can call capital M2, which will be the same mass but with a different velocity now v. Thus, for such a body, one can obtain for such a body one can obtain a change. One can obtain a semicolon. One can obtain what we call a change in momentum for such a body. One can obtain a change in momentum which will be uh, given by the difference between the two momentum values, capital M1 minus capital M2, which is the same as mv minus mu. And if we agree that small m is common, that becomes m into v minus u. That becomes what we call the change in momentum. It comes as a result of the body's velocity during motion to change. If a body's velocity changes during the course of motion, then it is expected to have a change in momentum. For example, example straight away. Let's have an example. Example, example. Find the change in momentum. Find the change in momentum. Find the change in momentum of a body. Find the change in momentum of a body of mass 5 kilograms, of a body of mass 5 kilograms, when its speed when its speed when its speed changes when its speed changes when its speed changes when its speed changes a from when its speed changes part A from 6 or from 7 meters per second to 16 meters per second. B, when its speed changes from uh, from 10 meters per second to 3 meters per second. Uh, I will not add anything. I will not add anything. So who is already if you're trying it out, I'm giving you some. Uh, our lesson is up anyway. I want to leave it to you to complete it. Is it okay? Can I leave that to us? You'll give me feedback.
Master, before you go.
Yes, please.
Master, this is not a question to what we've been studying, but I'm asking how can I reset my calculator?
Oh, uh, press shift, then the mode button. It will bring MC1 mode all. Then you press the all 3. Select 3. Then equal signs and it resets.